Hello everyone, this is Group 11 and this is our project for the subject Mechanics of Materials, which is combined load effect on the beam. And here is the theory part that we are going to explain the formulas that we use in this project. To get the bending stress, we use this formula, which is the flexure formula. And to get the shear stress, we use the shear stress formula. And here is the very important unit, which is the moment of inertia. We use it in the both formula for the bending stress and the shear stress. And here is the first moment of area, or the first area of moment. And here is the beam that given in the project with all the dimensions, the load in it. And we are going to solve the problem with respect to point K and H. And here are the results that we obtain, or we managed to get from the given information in the beam. So we managed to get the moment of inertia and the bending moment and the force for the shear stress for the Z and the Y axis. And here are the formula for the bending stress. After applying the result that we got earlier, we are going to get that the shear stress is equal to 15.834 megapascal. And here is the formula for the shear stress. And here we have the shear stress and the y-axis is equal to 0, since the point K is in the top. So the shear stress is going to be equal to 0 here. And we only have the shear stress for the z-axis. And to get that, we first have to get the first moment of area, or the first moment area, which is going to be equal to 22,520 millimeter cube. And here is after applying all that in the formula, we are going to get the shear stress is equal to 0.293 megapascal. And here are the result after solving the whole problem, or the whole beam. That we got all the shear stress here, or all the stresses here. The bending stress in the z-axis is equal to 11.72 megapascal. The bending stress in the y-axis is equal to 4.11 megapascal, and the shear stress in the y-axis is equal to 0, and the shear stress in the z-axis is equal to 0.293 megapascal. And here are the resultant stress for the bending stress is equal to 15.8 megapascal, and the resultant for the shear stress is equal to 0.293 megapascal. That was all. Now I'm going to leave you with the video, explain these stresses, or the reaction of these stresses in the beam. Thank you.
So now I will be explaining how the stresses react in our cantilever beam. So this is our y-axis and this is the z-axis, and here is our x-axis. And we have two loads, the 7,500 Newton, and the other load acting in this direction with 2,000 Newton. So due to this load, the 7,500 Newton, there will be a deflection in our cantilever beam. So our original plan is this one, and this is after the deflection of the point. So this is the distance that is caused due to the load. And now after cutting the cross section, we will have a stress distribution for the due to the bending force. So this is our stress distribution acting to the z direction. So here we will have a tensile force acting to the outside, and compressive force acting inside the beam. Now our second point load, which is the 2,000 Newton, it will cause a deflection to the z direction. So this is our original plan of the beam. So because of the second load, which is 2,000, it will cause a deflection at this distance. So after cut the cross section of our cantilever beam, the stress distribution will look like this. So our load is acting, the 2,000 Newton is acting to the left side. So our stress distribution of the shear stress will act to the opposite side, which is to the right side, and this is the z-axis. And this is another stress distribution, which is the bending force. So the upside will cause a compressive force acting inside the beam, and the second, which is a tensile force. And this is our y-axis. So that was all, and thank you.